Hi, everyone. In today's lecture, we are going to look at the key elements that go in the method section and also learn how to structure the method section and create visualizations to better convey your ideas. What goes in a method section? At first, we always start with the problem statement where we define the task formally. For example, is it an image recognition problem? Is it a speech recognition problem? We would define the inputs and outputs formally in this part. And after that, we would describe the overall approach of our proposed method and also hint at the different components of those methods. If your method has multiple components, this would then be followed by an explanation of the flow from the input to output from the different components. And finally, we would tie this up with the description of the loss functions that we use to train the model. We would also have figures of the method or the pseudocode that would explain what the actual method is doing and how it works. So to start off with the problem statement, here's an example where in this example, we considered the problem of learning an encoder-decoder network that classifies each pixel of an image I into its semantic class category. And then we define that what is the output image or the prediction itself. And we give a small example of what the nature of the problem is. This is how you would define the problem statement with 1 or 2 sentences. Here's another example of a problem statement where we first define the dataset that we use to train our model and what are the requirements, for example, the number of images and their corresponding ground truth, and how you actually learn the entire model and what are the different parameters involved. For the second part, we would talk about the overall approach. So this would give the readers a high-level understanding of what your method actually is. And then we would also explain the different components that are involved if you happen to have multiple components in your method. And then optionally, we could discuss the results. In this case, it would be the main results that we would like to highlight in our paper. And finally, we could also add the details on how to actually infer. Like, for example, how do we take the model and then use it to make future predictions on images or videos and whatnot. So the other subsection would be the description of the component itself. For example, if you have 2 components, you would start off with the first component, and then on that subsection, you would describe the motivation and the goal of that component. You could think of it in such a way that your main claims of using that component would go here. And then you would discuss how the component actually works at a high level. After that, you would discuss it in more detail with actually how the implementation of the component is, describing the flow from the input to the output, and then which builds up the loss function that you would use to train your system. If you have another component, this would be similar to the previous slide. Like you would discuss the motivation and then how it actually works at a deeper level. And finally, when we have the explanations of the different components, we would end with another paragraph showing how do we actually train and test our system. And you could also use this as a separate subsection itself. For example, you could name it overall loss function and define or add those details there, that how do you actually train or test your model. We would also have a figure which would basically give an overview of your proposed method at a high level so that readers understand what are the inputs and how they're being processed inside your method, and then finally the outputs of your model. You could also consider adding pseudocode of your method. This is a more popular or recent style that has been picking up on a number of papers that I've come across. So on the left, you see is more of like a pseudocode in terms of the actual code itself, which is basically becoming a trend right now. So you could add these details alongside your overview figure as well. And a more and a more classical approach would be the one on the right, where we have like, it is similar to a pseudocode, but it's not like really the actual code itself. So you could consider either of these options when you are writing your method section. Here's a template for the method section where we would start off with the problem statement, and then we would discuss the overall approach at a high level. And then we would go deeper into the method by discussing the different components that are involved in your method. And for each component, we would discuss the motivation and goal of the component, as well as the intuition. Here you would add the main claims that you are making in the paper for which you are using that particular component. You would discuss how the component works in general. And after that, you would discuss the details that go in building up your component by giving the intuition of the flow from the input to output, and then describe the loss function. After that, you would discuss how to train and test the method. And all of these details would be supplemented by an overview figure, which would basically visualize your method at a high level. And optionally, you could also have more than one figure where you could go deep into one single component and visualize how that works. And finally, you could also add the pseudocode on how the method actually works, what are the inputs, how it is being processed by the model, and then what is the final prediction that is being outputted from your model. So that's it for the method section. And on the next one, we would talk about the experiment section.